Hey guys, sorry I couldn't be there today to go over your review sheet with you. So I'm going to have you guys watch this video. I hope to be back at school tomorrow. If not, good luck on your final. Sorry, Ethan got a fever last night, and I'm going to be taking him into the doctor this morning and trying to get him healthy so he can get back and take the rest of his finals. So let's go over your review sheet. You've had some time in class to finish it up, and you worked on it yesterday. I do want to make sure that you go over the answers today and that you make any corrections on your paper so that tonight you can study your review packet and you know all the answers are correct and you can come in prepared to ace your DPM tomorrow. So let's start first up here in this section, the difference between distance and displacement. We have a little diagram of Bob. Bob walks from his home to the school, and then he walks to the park, and then he finally walks back home. His distance traveled is 10 kilometers because he travels 5 kilometers to school, 3 kilometers to the park, and then 2 kilometers home. So you add all of those distances up for his total distance, which is 10 kilometers. Bob's displacement is 0 kilometers because he started and ended at the same point. So he ended 0 kilometers away from where he started from. The difference between distance and displacement is that distance is a total of how far you've gone. So 5 kilometers plus another 3 kilometers plus another 2 kilometers. So you continue to add on more and more and more to your distance, and that's why distance always goes up. And then there's displacement, which is how far away you end up from where you started or from your reference point. In this case, the reference point was home. So when he was at school, his displacement was 5. When he was at the park, his displacement was 2. And then when he was back home, his displacement ended up being 0 kilometers. All right, let's jump over here, calculating speed. A car drives 15 kilometers in 30 minutes. What is the car's average speed? Well, the average speed formula is speed equals distance divided by time. In this case, the distance is 15 kilometers and the time is 30 minutes. But we need to convert that into hours because it wants us to calculate the speed in kilometers per hour, not kilometers per minute. So 30 minutes is a half hour or 0.5 hour. So I plug those into my formula and I get 15 kilometers divided by 0.5, and that's 30 kilometers per hour. Using the image to the right, which is really this image over here to the left of Bob, what is Bob's speed in kilometers per hour if it takes him 45 minutes to go from home to school? Well, speed equals distance divided by time, so his distance traveled from home to school is 5 kilometers, so that's the number we're going to use. His time was 45 minutes, so we convert that again into hours. 45 minutes is 3/4 of an hour, or 0.75 hour, and so 5 divided by 0.75 is 6.67, and that's rounded because the 6's just keep on going, kilometers per hour. All right, coming down here to understanding acceleration. You know what, let's come back to that one. Let's first go over this box, speed, velocity, and acceleration. How are speed and velocity similar? Well, speed and velocity both describe how fast an object is going. They're different though because velocity also includes the direction that the object is traveling in. So if I just know how fast it's going, like Bob up here, 6.67 kilometers per hour, that's his speed. But if I know that his motion is 6.67 kilometers per hour southeast towards school, then I know that that information is describing Bob's velocity because I know both how fast he's going but also the direction that he's moving in. Now, acceleration by definition is a change in velocity. So if there's a change in speed or a change in direction, then there's a change in velocity. Therefore, acceleration occurs. Calculating acceleration down here, what is the acceleration of a 75 kilogram object that has a force of 300 newtons applied to it? Well, I know 75 kilograms is a mass, and I know 300 newtons is a force. So I look at my reference sheet and I find this formula here, F equals ma. Since I'm looking for acceleration, this formula works out really good for me because I'm looking for this variable, and I was given this one and this one. So I plug it in, 300 newtons equals 75 times A. So to solve this, to undo this problem and solve for the acceleration, I divide both sides by 75, and I end up with 4 meters per second squared, which is the unit for acceleration, and so that's my answer. Over here then, 3 cars moving at 25 kilometers per hour are traveling along the same road. Describe the motion of each car. Well, this car is moving 25 kilometers per hour, so is this car, so is this car. So car 1 and 2 actually have a constant velocity because their speed is constant at 25 kilometers per hour, and their direction is also constant. They're going straight. Car 3, however, is on the turn of the road. So even though he's got the same speed as the rest of the cars, he has a different velocity because his direction is different. So car 3 is actually accelerating because of his change in the direction. So atomic structure is coming next. So we're leaving physics. We're going into atomic structure. This little line here is pointing to this space out here, the electron cloud. And this line is pointing to the nucleus. So starting with the electron cloud, it contains the electrons, which are negatively charged. Most of the electron cloud is empty space, but has most of the volume. So there's a whole lot of volume, but not a lot of mass in there. It has a very small mass. Remember that electrons only have a mass of 0.001 AMU. So even if I add all of the masses of all of the electrons up, I'm still only talking about a fraction of 1 AMU. The nucleus, however, contains the protons and the neutrons. The nucleus is positively charged because of the positively charged protons. The neutrons have a neutral charge, so they don't affect the charge of the nucleus. The nucleus has an extremely small volume. Remember that video we watched in class about the size of an atom? If we blew that grapefruit up to the size of a football stadium, the nucleus would be have the volume of a marble. So we're talking a very small volume, but an extreme amount of mass. The mass of the protons and the neutrons each have a mass of 1 AMU, and so you add all of the protons and the neutrons up together to determine the mass of the atom. Looking on to now page 2, we have 2 Bohr models, and you're supposed to fill out information about those Bohr models. So this first one here on the left, we look in the nucleus to see that it has 11 protons, it has 12 neutrons. In a neutral atom, the number of positively charged protons will equal the number of negatively charged electrons. So you count the number of electrons out here, and we also have 11. So the total charge of the overall atom is 0. The mass, I add the protons and the neutrons together, 11 plus 12 is 23. There's 1 valence electron, 1 electron in the outermost shell. And the nucleus has a positive charge because it has those 11 protons. It actually has a charge of plus 11 because of the 11 protons. Now this model over here has 13 plus charge in the nucleus, so you know there are 13 protons. There are 14 neutral neutrons. Counting the electrons, there should be 13, so that our atom is neutral. Not all atoms are neutral. There are some atoms that have a different number of protons and neutrons, but we will not be studying those ions. They're called ions in 8th grade. You'll study ions in chemistry. So remember that your number of protons will equal your number of electrons. So electrons are also 13. Add the number of protons and neutrons together in the nucleus to get my mass number of 27. There are 1, 2, 3 electrons in the outer shell, so that's my valence number. And the overall charge of the atom is neutral because I have my plus 13, minus 13 for my protons and my electrons, and those charges cancel each other out. The table here, remember the atomic number represents the number of protons. So if I have 3 protons, then my atomic number is 3. Looking on my periodic table then, my element is lithium. My symbol is capital L, lowercase I. I'm in group 1. Remember, groups are the vertical columns on the periodic table, so they go up and down. The periods are the horizontal rows on the periodic table. They go side to side. And then the number of valence electrons can be determined by the group number. So lithium is in group 1, period 2, and has 1 valence electron. If I have 4 protons, then my atomic number is 4. Using my periodic table, I can identify that atom as beryllium. The symbol is capital B, lowercase e. I'm in group or family number 2. I'm in period number 2. And because I'm in group 2, my valence is 2. If I have 12 protons, my atomic number is 12. Using my periodic table, I can identify this atom as magnesium. The symbol is capital M, lowercase g. In group 2, period 3. And because of group 2, there are 2 valence electrons. With 20 protons, the atomic number for calcium is 20. The symbol is capital C, lowercase a. The group number is 2. The period is 4. The number of valence electrons is 2. Bromine has 35 protons, so its atomic number is 35. It has a symbol of capital B, lowercase r. Its group number is 17. It's in period 4. And the number of valence electrons is 7. Now, notice that beryllium, magnesium, and calcium are all in the same group. Elements that are in the same group will have similar chemical properties because they have the same number of valence electrons. So make sure you maybe make a little note of that somewhere over here. Moving down, use the diagram below to answer the following questions. Well, here's a periodic table with a couple of locations identified with the numbers 1, 2, 3, 4. Which number represents an element that is least reactive? The right-hand side of your periodic table is the least reactive side. These are the noble gases. And so number 4 would represent the least reactive element. Which number represents an element that is most like calcium? Well, looking up here, calcium is in group 2. Any element in group 2 is going to be very similar to calcium. And so number 1 here is in group number 2. And so it's going to behave most like calcium. Which number represents an element that has 6 valence electrons? Well, you count your towers. Tower 1, or group 1, group 2. We skip over to group 13, group 14, group 15. Group 16 has 6 valence electrons, so number 3 on this periodic table would have 6 valence electrons. Moving into chemical reactions. And this video is going to be ending shortly. I'm doing them in smaller increments. So at the end of this page, the video will end and we will pick up with a second but shorter video. So answer the following question based on the chemical formula for glucose. The chemical formula for glucose is C6H12O6. This chemical formula tells me that there are 3 elements, carbon, hydrogen, and oxygen, and the subscripts tell me the number of atoms of each element. So how many atoms of carbon are there? Well, the subscript following carbon is 6, so there's 6 atoms of carbon. There are 12 atoms of hydrogen and 6 atoms of oxygen. If 2 compounds were dissolved in water, creating 2 aqueous solutions, aqueous just means that it's dissolved in water, and that's what they did. They took 2 substances, dissolved it into water. When solution A is combined with solution B, the observer notices that a white substance formed at the bottom and the temperature increased in the newly formed solution. List evidence of chemical and physical changes to determine which was observed. Well, there's really only one physical change that we can identify in this example, and that's of the dissolving. Anytime one substance dissolves into another substance, in this case water, to form the aqueous solutions, the process of dissolving is a physical change because you can get those substances back through the process of evaporation. But there were a couple of chemical change, or there was a chemical change that occurred, and the evidence was that white substance produced. That's called a precipitate. And also the unexpected change in temperature, which is also evidence of a chemical change. So guys, I'm going to go ahead and end this video right here at the end of this page. We're not done yet, so keep listening as the sub turns on the next video, and I'll see you just in a few seconds.